Okay, today we're going to do the flipped lesson for lesson 7.5 in your math books. Today's essential question is, how can you add and subtract fractions with like denominators? Okay. In this problem, let's go ahead and read about it. It says, Julie is making a poster for a book report. The directions say to use 1/5 of the poster to describe the setting, 2/5 of the poster to describe the characters, and the rest of the poster to describe the plot. What part of the poster will she use to describe the plot? Okay, so you can kind of see a picture of what's happening over here in this illustration. And it looks like she's got a small area for setting, a bigger area for characters, and a big area for plot at the bottom. Okay. First thing I'm going to do is I'm going to figure out what are they asking me. They want me to find out what part of the poster will she use to describe the plot. Okay. And the information I need to use is I know that 1/5 will be used for setting, and 2/5 for characters, and that the rest will be plot. Okay, so first thing I'm going to do is I'm going to shade 1/5 of my model down here to represent the part for the setting. So there's 1/4 or 1/5, sorry. Okay, and then I'm going to shade 2/5 of the poster for the characters. Next thing I'm going to do is I'm going to write an equation for the part of the poster used for the setting and the characters. I know that I'm going to need to use an addition operation to find that answer because the setting and the characters are going to be combined in one area. So 1/5 plus 2/5 equals, and you can clearly see it on our model that 3/5 is being used for the characters and the setting. The next question says, what does the part of the model that is not shaded represent? So that's this part right here. Well, she's using the whole poster for her book report, and if 3/5 is already taken for character and setting, that means what's left over, the rest, has to be for the plot. So we're going to write down here the rest of the poster. That will be plot. Okay, now since I'm taking a big piece and I'm finding the difference from a smaller piece, I know that the operation I need to use this time is going to be subtraction. Okay, so when I write an equation for the part of the poster she'll use for plot, sorry, I'm going to start with the whole. This 1 here represents the whole poster, okay? In this case, a fraction, I'm looking for a fraction that is equivalent to 1 in this model. The equivalent fraction for 1 whole in this case is 5/5. You can see 1, 2, 3, 4, 5 is equal to 1. Okay, so I'm going to start with 5/5, and I'm going to subtract out the 3/5 that were character and setting. And what's left should be what I'm going to use for the plot. So 5 minus 3 is 2, and there's still fifths, so 2/5 is the best answer. Okay. I guess you could also write that as 1 minus 3/5 equals 2/5. But I like to see those same denominators, so that's why I did the 5/5. Okay. So we know that Julie will use 2/5 of the poster to describe the plot. Okay, now we're going to move on down to the bottom where it says, what's the error? It says, Luke says 1/5 plus 2/5 equals 3/10. Describe his error. Okay, so really quickly I'm going to use some fraction strips to model it. If I have 1/5, okay, and then I have 2 more fifths, okay, adding means I'm combining them. 1/5 plus 2/5, okay. When I look at his work, it does look like he got 3 parts, okay, 3 of them. But what I notice is that he changed it to 10th size pieces instead of leaving it as 5th size pieces. When you combine or add fractions, you are just changing the number of pieces you have, not the size of the piece. And so if you change the denominator, then you're saying that the size of the piece changed, okay. So on my answer, I'm going to put that when you add fractions, let's say it this way. When you add fractions, you get more pieces. But the pieces don't change sizes or size. So the numerator should change, but the denominator will be the same. And I think I'm going to go ahead and just give a real quick fix on this so that Luke understands what he did wrong. Okay, so 1/5 plus 2/5 equals, well, the numerator is going to change, like I said, to 3, but the denominator will stay the same because they're still 5th size pieces, so 3/5. 1/5 plus 2/5 equals 3/5. Okay, now we're going to work on the example on page 410. In this example, you can see that we're working with common denominators. Okay, and really quickly, it says fractions with common denominators represent wholes divided into the same number of equal sized parts. To add or subtract fractions with the same denominator, you can add or subtract the number of parts given in the numerators. Okay, so we've been working with adding and subtracting fractions over the last couple lessons, and we've started to see this pattern happening. Okay, so a 1/4 size part plus a 2/4 size parts. Okay, the size of the part doesn't change; they're still 4th size parts, but the number of parts is now 3. So you can see in the equation, it's now 1/4 plus 2/4 equals 3/4, or 3/4 size pieces or parts. Okay, so we can do the same thing with this one to complete the equation. Okay, 3/6 size parts and 2/6 size parts. Well, the size of the part's not going to change, so I'm going to go ahead and write 6th size parts, but the number of them is changing. So 3 plus 2 is 5. So now I have 5/6 size parts. And in the equation, that looks like 3/6 plus 2/6 equals 5/6. Okay. Now the last example. This one, 7/10 size parts, minus 4/10 size parts. The size of the parts not changing. They're both 10th size parts. But the number of parts I have is going 7 minus 4 would be 3. Okay, so my equation, I have 7/10 size parts minus 4/10 size parts, and I see that common denominator, they're both the same size, so that means I'm going to take just the numerator and subtract 7 minus 4 equals 3, and they're still 10th size parts, so 3/10 is my answer. Okay, so now what we'd like for you to do is go ahead and finish the share and show section right here below on page 410. Make sure you at least get to number 5 and number 7 because those are the ones we'll grade together.